Welcome. In this video, we'll be integrating, and that is evaluating the definite integral of t squared times the square root of 16 minus t squared dt, and that's from 0 to 4. So we're going to do this using a trigonometric substitution. This one is of the form a squared minus x squared inside the radical, and in this case, namely, a is equal to 4, of course, since 4 squared is equal to 16, which is what we have here. So we're going to let, t equal 4 sine theta, then dt is equal to 4 cosine theta d theta. And of course, t squared is equal to 16 sine squared theta. So everywhere I see a t squared, I'm going to replace with 16 sine squared theta. And I'm going to replace dt with 4 cosine theta d theta. And I'll get to the limits of integration next. So this becomes the integral of 16 sine squared theta times the square root of 16 minus 16 sine squared theta times 4 cosine theta d theta. Now, the limits of integration, our lower bound is 0, so when t is equal to 0, replacing this t here with a 0, we're left with 0 equals this quantity. 0 equals 4 sine theta. So, sine theta equals 0. And of course, sine theta is equal to 0 when theta is just equal to 0. When t is equal to 4, I'm going to again replace this t here with a 4. 4 equals 4 sine theta, or sine theta is equal to 1. And sine of theta is equal to 1 when the angle is equal to pi over 2. So my limits of integration go from 0 to pi over 2. Now let's clean a lot up here. In front I have a 16 times 4 times the integral of 0 to pi over 2 sine squared theta. Inside my radical I can factor out a 16 from each term, and I'm left with 1 minus sine squared theta. And then of course at the end here I'm going to continue to multiply to just cosine theta d theta, since this 4 already came out to the front. Now using the Pythagorean identity, that is cosine squared theta plus sine squared theta equals 1, we know that sine squared theta, that is 1 minus sine squared theta, is equal to cosine squared theta. So I'm going to replace this sine squared theta, this whole quantity, with cosine squared theta. So I'm left with 4 squared times 4 times the integral from 0 to pi over 2 of sine squared theta. The square root of 16 here is just 4. And then the square root of cosine squared theta times cosine theta d theta. Now this 4 can just come out to the front, and I'm going to have 1, 2, 3, 4 copies of 4. So I'll have 4 to the 4th power out front times the integral from 0 to pi over 2 of sine squared theta. Now this cosine squared theta in the root is just going to be cosine theta times another cosine theta. I'll be able to rewrite all of this here as just cosine squared theta. So that's sine squared theta times cosine squared theta d theta. Now let's rewrite this one more step. And you'll see why I'm doing this in a second. I'm going to rewrite this as sine theta times cosine theta quantity squared d theta. Now let's put on our trigonometry thinking caps again and recall this identity. Sine 2 theta is equal to 2 sine theta cosine theta. And this looks really similar to what I have in here. So if I divide both sides by 2, I end up with sine 2 theta over 2 is equal to sine theta cosine theta. And now, of course, our quantity here is squared, so I need to square both sides. So I can replace this sine theta cosine theta squared with this quantity, and sine squared of 2 theta, And sine 2 theta over 2 squared is sine squared 2 theta over 4. So that is what I'm replacing this entire quantity with. So I have 4 to the 4th times the integral from 0 to pi over 2 of sine squared 2 theta over 4 d theta. So as you can see, I have rearranged this to make more space. So I'm going to continue to rewrite this. Now I have 4 to the 4th over 4 times the integral from 0 to pi over 2. And let's recall some trig again. So sine 2 theta, sine squared 2 theta can be rewritten as 1 minus cosine 2 times 2 theta over 2. So let's rewrite this integrand as 1 minus cosine 4 theta over 2 d theta. Now I can finally evaluate this integral. So I have 4 cubed over 2, and that's just from simplifying these constants here, times theta minus sine 4 theta over 4, and that's evaluated from 0 to pi over 2. I can now evaluate this at my limits of integration to get 4 cubed over 2 is equal to pi over 2 minus sine of 4 pi over 2 over 4 minus 0 minus sine of 4 times 0 over 4. Now every term vanishes except 1 because all those 3 become 0. So we're left with 4 cubed pi over 2 squared, which is just 4 cubed pi over 4, or 4 squared pi. 4 squared is 16, so this just becomes 16 pi. So this entire integral here is equal to 16 pi. I hope this video was helpful.